Hello friends, welcome to my channel Computer Science Lectures. Our today's topic is conductors, semiconductors and insulators. Materials are classified into conductors, semiconductors and insulators according to their electrical conductivity. They can also be classified in atomic terms like valence electrons, free electrons, energy bands, energy gap. So we will see these terms in this video. First, do you know what is valence electrons? We will start with the term atomic structure. Here you can see green color circle which is the center of the atom which is called nucleus. Nucleus contains neutrons which are uncharged particles and protons which are positively charged particles. That is the reason nucleus is always positively charged. Electrons surround in the orbit or path in the atom around the nucleus. So you can see there are three different orbits and electrons are moving around those orbits. Electrons are always negatively charged. So you can see the structure of atom which contains protons, neutrons and electrons, and in the atom there is one nucleus which is the center of the atom which contains neutrons which are uncharged particles and protons which are positively charged particles forms nucleus which is that's why nucleus becomes positively charged. Okay, then we'll come to term valence electron. Then what is valence electrons? The valence electron is the one which comes in the most exterior shell of the atom. Do you know the electrons are arranged in the atom like in first orbit there should be only two electrons, means 2 into 1 square, 2 electrons. In the second orbit there should be 2 into 2 square means 8 electrons. In the third orbit there should be 2 into 3 square means 8 electrons, 18 electrons. So the remaining electrons moves around exterior shell of an atom. Sometimes it is 1, 2, 3 but less than 8. So the valence electrons already reside in the exterior shell of an atom. Got this point? Okay. We will move to our next term, free electrons. Valence electrons that get enough energy to leave the outer shell of an atom are called as free electrons. You can see in this image. Valence electrons, when become free electrons, are responsible for conduction. In simple words, students near the exit gate can easily go out from this class now as they are free to move. They can roam in the school or college premises. These free electrons are responsible for conduction in substance. So, to understand these terms, again take the image of atomic structure. You can see there are some electrons in the outermost shell of an atom. So when applied extra energy to the atom, some electrons attract to nucleus of other atom. That means they leave the outer shell of present atom to move surrounding the other atom. These electrons are called free electron or conduction electron also, because these free electrons are responsible for conduction. So moving to our next term, energy band. We can we know that what is the structure of atom. The center of the atom contains nucleus which is positively charged, and surrounding those there are different orbits or path, and electrons revolve around those orbits. So suppose we consider the energy possessed by the first orbit electron, we call it R1, or there is some energy possessed by second orbit electron, we call it R2. This energy will be definite, that is fixed. The two electrons of the first orbit will be having energy, that is R1, and the eight electrons will be having energy R2. So what will happen if this atom will combine to create a solid? We can see in this image. See, these atoms are combining to form a solid substance. So when these atoms are combined to form a solid, what happens? The electrons in the first orbit or second orbit, they try to attract nucleus of another atom, or try to repel electron of another atom. This process goes on and on and on. So the energy possessed by first or second orbit of the atoms change slightly, it increases or decreases. So these the range of this energy is called energy band. Okay, there are some important energy band, we will come to know that about in the next. Important energy bands are valence band. This band may be filled with completely or partially. The energy band possesses the valence electrons, called valence band. Conduction band. This energy band which possesses the conduction electrons is called conduction band. Forbidden energy gap. The energy gap between the valence band and conduction band is known as forbidden energy gap. So, in the previous slide, I told you that when electrons from first orbit or second orbit try to attract to a nucleus of another atom, or repel from electrons from the another atom, they slight increase energy or decrease energy. There will be slight decrease or increase in the energy. Thus, they will form energy band. We know that valence electrons are those which are on the exterior shell of an atom. So when these valence electrons try to move from one atom to another atom, then they generate some range of energy. So that energy band is called valence band. When the free electrons try to move freely in the solid, they generate some range of energy. That is called energy band is called conduction band. And there is a term contain, we call it forbidden energy gap or simply energy gap. The energy gap between the valence band and conduction band is known as forbidden energy gap. This energy gap is different in all three materials. Like in insulator, it is very large. In semiconductors, it is not too much, but there is some energy gap in case of semiconductors. And in conductors, conduction band and valence band overlap each other. So we will come to our main topic, that is conductors, insulators and semiconductor. First we will know about conductors. So the conductor is a type of material that allows the flow of charge, otherwise known as electric current. Most commonly electric conductors are made from metals. Such materials allow the current flow due to presence of free electrons or ions which starts moving when voltage is applied. The conductors have very low electrical resistance, that is the opposition to the current, and depend on the length and width of the conductor. It increases with the increase in temperature. Now come to our next term, semiconductor. Semiconductors are materials that have conductivity in between conductors and insulators. They can block or allow the current flow from providing total control over it. They are mostly modified by adding impurities called doping. It modifies its properties like unidirectional current flow or amplification or energy conversion extra. The electrical conduction inside semiconductor is due to the movement of electrons and holes. We will discuss these terms later, doping, holes, and all those things. Now, our third material is insulator. An insulator is a material that has very high electrical resistance and it does not allow the flow of current. There are no electrons in insulators, thus they do not conduct electricity, thus they are used for protection against shock. Now we will come to the difference between conductors, semiconductors and insulator. A conductor is a material that allows the flow of charge when applied with a voltage. A semiconductor is a material whose conduction lies between conductor or insulator. An insulator is a material that does not allow the flow of current. Another difference is the conduction in conductors is due to free electrons in metal bonding. The conduction in semiconductor is due to the movement of electrons and holes. An insulator, there are no free electrons or holes, thus there is no conduction. So there are some more differences. There is no low or energy gap between conduction and valence band of the conductor. It does not need extra energy for the conduction. In semiconductor, the band gap of semiconductor is greater than the conductor but smaller than the insulator, that is 1 electron volt. Their electrons need a little energy for conduction state. In insulator, the band gap in insulator is huge, that is 5 electron volt, which need an enormous amount of energy like lightning to push electrons into conduction band. Resistivity of conductor is very low, that is 10 to the power minus 5 ohm meter. Resistivity is normal in semiconductor, 10 to the power minus 5 ohm meter to 10 to the power 5 ohm meter. Resistivity in insulator is very high, that is 10 to the power 5 ohm meter. Some more differences are: in conductor, less than 4 valence electrons in the outer shell are present. In semiconductor, there are exactly 4 valence electrons in the outer shell are present. And in insulator, there are more than 4 valence electrons are present in the outer shell. Examples of conductor are gold, copper, silver, and aluminium. Examples of semiconductor are silicon, germanium, selenium, antimony, gallium, arsenide, known as semi-insulator or boron, etc. Examples of insulators are rubber, glass, wood, air, mica, plastic, paper, etc. So for today, that's it. If you like this video, please like, share and subscribe. In the next video, we will discuss about semiconductor diode or PN junction diode, what we call it. So for now, bye. Please like, share and subscribe this video if you like it, or comment your feedback. Thank you.